All right, welcome to Good Choices. And I say that in earnest because this is what I'm going to do. Mic check 1, 2, 3. So, yeah, it was pointed out to me that I had audio issues on my best video where I had a revelation eureka moment about what the difference is between standard in, out, and error. So, this is how I'll be starting my videos from now on. I think what happened is my Focusrite connection. I saw even at the beginning of the video, I wasn't getting this. So from now on, thanks so much. I will be starting all my videos with a mic check 1, 2, 3. And if this isn't up, then that's a problem. I should probably also check the output, but that's not as big of an issue. So mic check 1, 2, 3. Okay, looks good. We're in the red sometimes, which isn't great, but yeah, I'm going to be continuing my automate your network series. That's one for me. I'm getting a lot of great feedback on my LPIC series, so I'm going to keep that going. If I have to choose making one or the other, I'll probably choose the LPIC because of all the great feedback I'm receiving on that. But just for me to kind of enjoy my life, I'm going through this book. So I'm on chapter 2, Why Automate the Network. All right, so the remains of the old must be decently laid away, the path of the new prepared. That is the difference between revolution and progress. Okay, so I guess what Henry Ford means to say is progress is like making incremental changes based on the old ways, and like revolution is like just completely getting the old ways out of the way so that the new way is the only thing we're concerning ourselves with. The time for change has arrived. Enterprise networks have outgrown and outpaced the ability to effectively manage and maintain themselves using traditional tools, and these are enterprise networks. That's service provider networks and data center networks, I think, have done that earlier. Historically, network management meant manually gathering point-in-time information from or making configuration changes to individual devices. Networks are often designed using a configuration command-driven approach as opposed to a data-driven approach. Staff manually execute commands at the CLI to gather information or perform changes. Information is often regarded to confirm the state of the network after changes are made. The ongoing creation and maintenance of network documentation is also performed manually. Hours of effort is required to make changes, often repeating the same commands only on different devices. Inevitably, troubleshooting is required because of errors made using the manual methodology. Network automation just magically solves all those problems. Yeah, right. But anyways, maybe it does. That's why I'm reading this book. So before I go on, I want to ask the AI something I'm just curious about. In addition to enterprise, data center, and service provider networks, name some other kinds of computer networks.
Certainly. Understanding various types of computer networks will certainly give you a broad perspective on the networking industry, aligning well with your goal of having a bird's eye view of different networks and their design principles. This knowledge can prove to be useful in your career growth and mastering a niche like network automation. Here are some types of computer networks besides enterprise, data center, and service provider networks. Local area network, LAN, typically found in homes, schools, and small businesses. These networks connect devices over a relatively short distance. Learning about LAN design could be foundational for grasping more complex networks. Wide area network, 1. These networks span a large geographic area and are often used by businesses and ISPs to connect multiple LANs. Understanding WAN optimizations can be very valuable for remote work infrastructure. Personal area network, PAN. Commonly used for connecting devices like smartphones, tablets, and laptops over a short distance. It could be interesting to explore how PAN security protocols work. Virtual private network, VPN. A network that allows for a secure connection over the internet. As remote work becomes more prevalent, understanding VPNs can be a key skill. Campus area network, CAN. Typically used in academic settings, these are larger than LANs but smaller than MONs and are optimized for a certain geographic area like a university campus.
I mean,
Metropolitan
that's
area
an
network,
enterprise
MAN.
network.
These are ideal for connecting multiple LANs within a specific geographic area, such as a city. A lot of service providers offer MAN services. Home network, generally a type of LAN set up in a home, connecting various personal devices. Familiarity with this can be useful for troubleshooting and for understanding consumer-grade networking hardware. Storage area network, SAN. These are specialized networks designed to provide fast and reliable access to storage resources and are often used in data centers. Peer-to-peer network, direct connections between devices without the need for a central server. This is more common in decentralized systems. Overlay networks. These are virtual networks that are built on top of another network. They are often used in cloud computing environments. Industrial networks. Used in manufacturing and industrial settings, these networks are designed to be extremely robust and reliable.
Okay, so yeah, like I guess let me ask you one more thing. This idea of there being a data center, an enterprise, and a service provider network, does this idea make any sense, or is it better to think of it in terms of a storage area network, SAN, a campus area network, CAN, and a WAN? Is that a better way to think of a data center, enterprise, and service provider network as campus area networks, storage area networks, and wide area networks? Or does the network, thinking of the network as enterprise, service provider, and data center, make sense?
B. The way you categorize and think about networks can vary depending on the context in which you're working or the particular goals you're trying to achieve. Both the enterprise, data center, service provider classification and the SAN, CAN, WAN classification serve specific purposes and have their own merits. Since your major goals include mastering a niche like network automation and gaining a bird's eye view of the industry, understanding both perspectives will make you more versatile and well-rounded in your field. Enterprise, data center, service provider, enterprise networks. These are generally internal networks within an organization. They can include elements like LANs, WANs, and more recently cloud services. In an enterprise setting, the focus often lies on internal communications, device management, and internal services.
Yeah, that's what I thought.
Data center networks. These are specialized environments.
So you can't really just say, like, you know, the LAN, the WAN, and the SAN, you know, are like bones and ligaments and all that. Like, it's useful to talk about an enterprise network, a data center network, and a service provider network because it's useful to talk about an arm, a leg, and a torso, you know. So, like, they're comprised of things, sometimes the same things, but altogether they're very different from one another. So here's some key takeaways. When you use the terms enterprise, data center, and service provider, as those terms are used, for example, on a Cisco certification track, what we're talking about is classification that is useful for understanding the purpose, scale, and primary uses of a network. But when you use the terms such as SAN, CAN, and WAN, which would not be Cisco certification exam tracks like enterprise, data center, and service provider would be, but contents of exam questions, not speaking to it specifically, but, you know, hypothetically, you would see those terms SAN, WAN, and CAN in an actual test in any one of those tracks. So that classification is more about a technical specification, topology, and geographical reach. So, like, the purpose of a WAN could be to connect your enterprise networks together. It could be to connect your head ends together for your service provider. It could be to connect your data center to your enterprise. You know, so a WAN is not useful necessarily for understanding the purpose, scale, and primary users. The geographical reach, topology, and specifications, kind of more like the down and dirty technical specifications. Those are like more technical terms, you know, that you'd use like as an engineer. And the enterprise, data center, service provider, those are more like everyday colloquial language that you'd use just for communicating with people about networks and people who aren't necessarily engineers. All right, so moving on. Scale. The size and scale of a modern network has grown exponentially to accommodate the needs of organizations. Networks that started out as a few switches and a router are now large-scale enterprise networks. While logical networks evolve and grow, the tools used to manage physical devices remains stagnant. On the campus, we now see VoIP phones, wireless access points, IoT, security cameras, print fleets, so I guess for printers, desktop fleets, so like groups of desktop computers, and meeting room equipment. In the data centers, large physical and virtual footsteps are not uncommon. Worldwide WANs with switching and routing in each remote office is now commonplace. The device boom has not slowed, with even more devices being added to the networks without the appropriate centralized automated management solutions available. Network management starts with the console cable and a local CLI, command line interface. Remote access to the CLI over a management IP address must be enabled by the administrator. IP stands for Internet Protocol, but I won't unpack every single one. Now imagine network technicians still needing to go to the physical console of every device to manage it. It sounds unreasonable, a lot of driving, but only remote access to the CLI has been centralized. The same methodology of logging into the CLI to change the device is followed as if the operator is virtually at the console. In fact, these remote connections are known as virtual teletype or VTY lines. At the scale of today's network, connecting to the CLI of every device to manage the enterprise is simply unachievable. Even with a large, capable network operations team, everyone is going to operate, configure, and manage each device their own way. This leads to configuration drift and a lack of consistency at scale. Was drift mentioned earlier? I can't remember. I'm just curious about that. Let me look it up. Oh, it's only mentioned twice in this whole book. Okay, well, this is the first time it's mentioned. Configuration drift and a lack of consistency at scale. So automated solutions scale with the network as device configurations are templated. Small feature-specific modular templates ensures each device is standardized. When new feature requirements arise, the configuration requirements are templated and released at scale, updating the network standards uniformly. Unique, device-specific, meaningful information is modeled in a data dictionary. This dictionary holds all the variables used to compile a unique configuration for each device. Code can be written modularly to match the topology of the network by creating playbooks specific to the environment, such as campus, data center, WAN, or cloud. Ansible playbooks ensure code simplicity, readability, and development flexibility. All right, so the next section is complexity. The complexity of networks has dramatically increased. Virtual route forwarders, VRFs, QoS, quality service, wireless connectivity, cloud connectivity, virtual private network, VPN, first hop redundancy protocols, FHRP. So that's like a first hop redundancy protocol is like VRRP. That's the open standard used by every device manufacturer. Then there's like HSRP used by Cisco, and then GLBP, which is a more advanced Cisco feature, a more advanced Cisco first hop redundancy protocol. Okay, and then, and it says that right there, such as hot standby routed protocol, HSRP. This is a Cisco book. Virtual switching systems, VSS, and security and identity services, such as 802.1x. That's the protocol used to prevent unauthorized devices from connecting to a port, have all stressed the capabilities of both engineers who design and operators who run the network. So abstracting important data from the network configurations allows operators to see the network devices as a collection of human-readable variables and dynamic templates. This drastically simplifies network design. Human readability of the intended configuration for a device also reduces the technical requirements needed to understand how a device is configured. The knowledge required to execute commands and understand how a device is configured is abstracted because the device information is presented as a human-readable data model. Alright, so next section is documentation. Network documentation is extremely important, especially during times of crisis. However, it is often overlooked by day-to-day operations. Changes may or may not be reflected in documentation. Files may be scattered across a variety of sources such as local drives, Microsoft SharePoint sites, or network shares. Stale or out-of-date documentation is of little value to an organization. Documentation that does exist is often represented as complex video diagrams, large Excel spreadsheets, or text files that do not interact with the network dynamically. Documentation should be thought of as a key component and advantage of the network automation solution. The scope of automation is not limited to making changes. Part of the TFS repository master branch should be a folder structure containing both the dynamic documentation Ansible playbooks, as well as folders for the generated output artifacts. Automated documentation can be built directly into the CI/CD pipeline, creating comma-separated value, .csv, markdown, .md, or text files. These files are then incorporated into Git commands and pull requests, becoming part of the code database and repository. TFS and VS Code can view these files natively, representing a customizable view of the network as code. These artifacts include the intended automatically generated configuration files, as well as the data model variables manipulated to express the information in different formats. For example, it is possible to automatically generate the following documentation for each device based on data model variables. So instead of having to write down all your VLANs, especially when they change a bunch, you can automatically put those in your documentation based on what they are. So if somebody goes in and changes a VLAN, it's authorized approved change. You no longer have to go through and update all your documentation. The documentation just comes from your data model. So, which is automatic. The variables in your data model are automatically populated by what's on the network. So that can be the case for VLANs. It can be the case for VRFs, routing protocol configuration information, static routes, interface information, whether an interface is up or down. That's a big one too, because you can document the the services that are on your network. So like you can document whether a service is all configured and ready to go but just hasn't been delivered yet, whether the service is completely ready to go, ports up, traffic is flowing, everything's good, whether the service is down because you want to remove it from the network, so you shut the port down but you still need to gather the gear and stop the billing. So like, that's hard to do manually and to keep that all straight. So that's one thing you can do based on your data model variables. The other thing is the mode, access to a trunk. For example, like if it's like the encapsulation, if you have of the sub interface, so like more VLAN information, port channels information, member ports, IP addresses, access control lists, ACLs. In fact, any information represented in a data model can be transformed into dynamic documentation files. This allows for desired information about any device on the network to be automatically generated at build time and available through TFS. The history for these documentation files is included as source and version controls. When adding or removing code, the resulting documentation updates are automatically performed, reflecting the changes. All right, and I will be right back. All right, welcome back. 20-minute mark, so let's keep going. Oops, and I didn't close it. It's right here. Okay, so standards. Corporate standards are very hard to maintain over time as networks evolve and transform, and the worst thing that can happen is you can have a corporate standard that makes zero sense. And it's like, the corporate standard is wrong. Can we change the corporate standard? No, because you're a network engineer 1, and we have network architect 4s making, 10 times what you're making that are out to lunch right now. So often the pressures of projects and deliverables of day-to-day work demands leads to standards being overlooked, put off, or ignored. And again, none of this is malicious. It's like, if they have a standard that makes zero sense, and your job is to apply that standard to the network, you have to sometimes make a trade-off. Like, do I want to follow this standard exactly, or do I want to avoid an outage? It's like, for me, it's like, I want to avoid an outage, so like I'm just going to ignore the standard. I'm going to do it right. And now sometimes that can be a recipe for disaster, because you think you're so smart, and then you cause an outage by not following the standard. But as I said, like, if you see the people on your network that way, like, they're all just idiots, like, I don't think things are going to go well. Like, you have to look at these people as, people who really know what you're doing, and you have to develop your innovation to beat those people, not to beat the worst person on your network, to beat the best person on your network. So like, the pressures of projects and deliverables of day-to-day work demands lead to standards being overlooked, put off, or ignored. It's not because people are, doing that maliciously or want to save time. It's because sometimes the standards make zero sense. All right, so natural configuration drift can occur over time as network devices and IP addresses come and go. Like, literally, sometimes you will see a corporate standard published by a network engineer, that's worked for 20 years, has a CCIE, that like forgets that there's an implicit deny on the ACL. Like, that's, yeah. So like, okay, well, I'm can understand what's going on this network. I don't have a CCIE, but I have my own years of experience, and I held a CCNP for a while. I'm working towards my CCIE, and yes, there are some cases where you wouldn't put a permit any, but there's really no case where you wouldn't make that implicit deny all explicit. So it's like, yeah, like, it could be a corporate standard that just doesn't really follow the best practice, whereas like, we're relying on that implicit deny any, but oh, look at this. If we were to do that, it would cause this really big problem. So what they mean is they mean a permit any. So like, if they have a series of deny statements in the ACL, and then that's it, they're denying everything. So like, there has to be a permit any. And like, this is what I'm talking about with corporate standards. It's like, they're overlooked, put off, or ignored because there's just this assumption being made that the people making the corporate standards are the only people in your organization that think, and that's a bad assumption to make, because like, it matters to have people thinking in advance what goes on the network, but it doesn't matter to maliciously adhere to those standards no matter what. So like, of course, there's going to be standards that are overlooked, put off, and ignored, because sometimes the standards are wrong. All right. So natural configuration drift can occur over time as network devices and IP addresses come and go. If network devices continue to operate, misconfigurations or poor standards may go unnoticed. When identified, these cosmetic corrections may be deemed a low priority. So, and the other thing is when identified, it's, yeah, okay. This is actually really good. Yeah, it's self-explanatory. So Ansible's dynamic templating guarantees a standardized configuration for every device. Complete configuration coverage is achievable, and every line of code in the running configuration can be derived from a template. Having accomplished full idempotency between the source of truth and the device configuration, guarantees intent-based standards are uniformly applied. Scale is not a problem with this approach, nor is the human error factor. When new standards arise or changes to existing standards are required, only the centralized templates and data models are updated. These changes are pushed through the automation engine, delivering the new standards to the network. All right, so golden configuration. Sometimes referred to in Windows operating system administration as a desired state configuration, a golden configuration has many names. Using Jinja 2 templates and YAML data models, a golden configuration for each device in the network is achieved using software development methodologies. Logic within the templates is used to intelligently generate device configuration commands. These configurations are applied at scale to all devices, including in the Ansible hosts.ini inventory file. The master branch represents the golden configuration for the network. Automated builds package the various artifacts from the master branch and provide a version number for that iteration of the network. When changes are required, however, minor working branches are created for code to be developed and tested. Frequent get commands during development are used to check changes into the working branch. A pull request is used to merge these accumulated changes into the master branch, which is then deployed into production, updating the standardized golden configuration at scale. Alright, so the next section is security. I feel like I kind of need another break again. Sorry, I just made a video before this, and yeah, I need another break. Alright, feeling a lot better. I have to do a posture check. Right now, check your posture. If you got bad posture, fix up that posture. You'll thank me later. Alright. So next section is security. Some of the largest security breaches occur because Telnet is open on a port with a public-facing IP address. Security standards and best practices can now be hard-coded into templates guaranteeing enforcement of policies. Often, complex configurations are required on interfaces at the access layer to address security risks. Consider the access layer and all the following security standards that should be implemented. So, spanning tree toolkit commands, bridge protocol data unit controls, so they can't change like which links are being blocked. That could be like if you're blocking a link to, yeah, so they can't change which links are being lost. And then like port fast, they could do a denial of service on your network by like shutting it down for 45 seconds by like toggling the port fast and having spanning tree like recalculate. All right, so 802.1x or port security commands, self-explanatory, data and voice, VLANs, QoS settings, CDP settings, power over Ethernet, PoE settings, native VLAN established, native VLAN applied on trunk ports, NTP source, security banner, presented at login, AAA, radius/TACX+, ACLs on management ports, VLAN 1 disabled. Oh, so these are the on the access layer. These are the security standards that you should have enabled. So you should have control of your BPDUs. You should have port fast enabled. You should have 802.1x. You should have VLANs that are separated out as is appropriate. You should have QoS set up. You should have you should have QoS configured in a secure way. You should have CDP set up in a secure way. You should have your PoE, Power over Ethernet settings set up in a secure way, so that people can't like take power from your network by plugging into an unauthorized port. Native VLAN needs to be established. Native VLAN needs to be applied on truck ports. NTP source needs to be updated. NTP needs to be synced. You need a security banner. So get out of here. You need user accounts, of course, so you can track what people are doing, if there's authorized users in or not. Track their changes as well. AAA accounting. TACX and Radius, you want them to authenticate to a remote server to give you even more control, not just on the local device, and then you can see what's going on easier in a more centralized way. ACLs, you want to block access to those management ports except from validated entry points, and then you want to disable VLAN 1. You want to put the native VLAN on another VLAN for Cisco devices. And that's because VLAN 1 is like a special VLAN on Cisco that allow the device to be just like plug and play. So like you can accidentally make the network more accessible than you intended if you don't disable VLAN 1 and put your native VLAN on a different VLAN. All right, so security requirements, if missed or incorrectly applied, lead to vulnerabilities and threats within the network. These vulnerabilities can be exploited, lead to outages, or bring about data loss in certain scenarios. Having a guaranteed templated configuration ensures that important security components are hard-coded into every template and applied to both the device's global configuration as well as every interface configuration. Every access port throughout the campus can now be configured the same way and will automatically include security posture standards. All right, so agility. In an in-demand, in an on-demand world, networks continue to be the bottleneck of many projects, and it's certainly a bottleneck of my project, for God's sakes. I mean, it's good today, but like, it's still just 80. One of the driving factors for moving to automation is the agility it offers. Most of the common changes to the network become updates to existing data models. When new feature requirements arise, such as the need for multicast, new templates along with new data model variables will be developed. The feature is then released and incorporated into the orchestration of playbooks as a new task. A very repeatable modular process evolves, which provides the agility to deliver projects more frequently. Design. Traditional network design often centers around the device configuration commands. While these commands are essential at implementation, it is the data that should drive network design. Network engineers' new responsibilities include crafting human-readable data models and the logic that drives the dynamic templates. Existing or new dynamic documentation should reflect new features as templates are added or updated. Thinking about data first and configuration second, network design evolves. All right, next section, deployment. The biggest advantages found in network automation are often on the operational side of network management. Large-scale changes are often very difficult to roll out to an enterprise, including QoS to a network, for example, means touching all devices on all layers of the network, often with different code per platform. Devices using multi-layer switching, also known as MLS, or modular quality of service command line, MQC, leads to different requirements and configuration commands by platform. Operations receives approved, finalized network designs along with deployment steps from the network engineers. This often requires weeks or months to then complete the delivery to campus from start to end. Network automation, or even a hybrid model where administrators run Ansible playbooks manually, solves operational headaches related to deploying the configurations to the network. Development time is drastically reduced when using Ansible playbooks, while quality and accuracy significantly increases. How far do I want to get? I could get past chapter 2 if I just keep on keeping on. You know what? Let me do that. So, this is, we just, we read about agility, we read about design, we read about deployment. I don't really remember reading about deployment. I remember reading about this. So this often requires, I'll start from there. Leads to different requirements and configuration examples by platform. Operations receives, I remember this, yep. This often requires weeks or months to then complete the delivery to campus from start to end. So operations receives approved, finalized network designs along with deployment steps from the network engineers, which takes a lot of time. Network automation, even a hybrid model, reduces the time and the headaches. And you can use it just with Ansible playbooks, which are free. All right, so operations. NetDevOps will dramatically change network operations role in the organization. A library of canned automated Ansible playbooks develops over time. Automated builds and deployments will trigger whenever approved changes are merged into the repository. Operations are often tasked with running the network day to day, incorporating and deploying the changes coming from projects or network engineers. Operations will now learn to develop and use code. If the deployment, network reconnaissance, and documentation aspects of operations can be automated, it will allow the operations team to focus on the day-to-day aspects of the network management, along with new automated tools used to gather the information needed to run the network. With that said, the network may still have the need of an NMS, network management software, for platform health monitoring. There may be network appliances or controllers that are not good candidates for automation, or there may be non-SSH systems on the network that are non-automatable using Ansible. And see, that's a problem too. But anyways, intent-based. The human-readable nature of this methodology allows for a true intent-driven model of the network. The configurations are abstracted into the templates, so focus can be put on the data models. Intent for each device or group of devices can be expressed in a non-human readable form. Idempotent Ansible playbooks combined with check mode can tell exactly if a device is running config matches intent and if the Ansible playbook would have added code. Utilizing the differential option --diff allows the operator to see what differs between the two configurations and can also be displayed indicating any commands present on the device but missing from intent. New appliance-based solutions are available that offer a GUI-driven intent system. Drag and drop intentions in the GUI are translated to configurations that are automatically pushed to the devices. These new intent-based appliances are the biggest competitor to Ansible network automation. Either purchase and configure the appliance, hoping it does everything advertised, or build an in-house Ansible automation framework. Yeah, and this is what I want to be able to do. I think this is a really valuable. I mean, you can measure exactly how valuable it is. Like, let's say they they purchase and configure an appliance, and it costs them $5 million. You know, if you can match that performance or better it just with your in-house, you know, just for the price of your salary, you know, you save this company, well, over the course of a year, millions. Unless you can, unless you're really good at negotiating salary. I am not that good. All right, so source of truth. Every network should have an authoritative artifact identifying what is the correct intended configuration for each device. Source of truth is a trusted artifact that network engineers and operators can reference with certainty. This can be an IP address, a static route, an ACL, or configuration command. It can be required when designing new solutions, adding new devices, scaling the network, troubleshooting problems, or rebuilding a device after failure. Where is a network's source of truth? Is it a network management system, flat files in folders in a network share, a Microsoft SharePoint site, the network device running config itself? Using the new network development lifecycle and DLC, a living source of truth in TFS exists. A rich repository containing data models, templates, and Ansible playbooks, which also stores the compiled intent-based, dynamically generated configuration files for each device. Yeah. TFS is a single centralized, I forget what this stands for, RBAC controlled, RBAC, what does that stand for? RBAC controlled, role-based access. So you can decide who and who does not have the ability to access it. Source of truth to modify it. So like, you know, it's your source of truth. So like if you have some contractors, like you can lock them out from changing the source of truth. And if the source of truth is just the network configuration itself on the network itself, you can't do that because you're hiring them to work on the CLI. So source of truth for the network. TFS repository can be used as a reference for all future network designs and troubleshooting. Source of truth means browsing for data models or templates that create the configuration or the compiled output showing the exact device configuration without ever needing to connect to the device CLI. Other artifacts such as the routing tables or firewall rule lists can also be stored in the source of truth as output from dynamic playbooks. Having this is not something every network can produce. However, it is indispensable when designing new features, planning future changes, dealing with network failures, or troubleshooting problems. All right, change management. Network automation can help simplify the change management process as it is a natural part of a pull request. The master branch can be locked and only approved changes allowed to be merged through a pull request. An approver has all the necessary artifacts to approve, deny, or conditionally reject a pull request, asking the developer for more details. Documentation is automatically generated, and the changes to either the data model or dynamic template of a device is obvious and highlighted in TFS for the approver's benefit. So sample processes of change management are for a new requirement, a change, a feature, or correction, or refactoring. it would be added to the work board in TFS. The work would then be assigned. A new working branch would be created. The engineer would perform git pull, downloading the updates to the central repository. The engineer changes the new branch in local VS Code, git checkout, development work, add, change, delete code, testing, check mode, documentation generated. Engineer performs commits often, ideally for small related changes. Engineer performs a git push, uploading the changes to a central repository. Engineer submits a pull request in TFS. Pull request triggers approval workflow. Approvers/reviewers are notified. Pull request is approved or denied. Approved request merged into master branch. Automated build triggered. Documentation updated. Automated test triggered. Automated release scheduled. Change delivered to environment through Ansible. Alternatively, if full CI/CD automation is not yet established, operators execute approved Ansible playbooks manually. All right, so problem resolution is another problem resolution is another reason, or is another thing. Yeah, is another reason to automate the network. It's another thing that network automation can resolve. It can resolve, or it can provide resources. No, it can provide problem resolution. So being able to quickly identify, troubleshoot, and resolve network problems becomes an easier process with the addition of these new tools. CLI skills are still required, but think of automation as an augmentation and extension of the network team's skills, providing results at scale in near real time. The source of truth can be referenced using pull requests and commit information to find the latest changes and how they relate to outages. The automated documentation can be used to confirm configurations and key information about devices without the need to connect to any device. Ansible can also be used to rapidly deploy a fix to the enterprise if a flaw is found or a change to multiple devices is required to resolve an issue. This method has the benefit of being included in the source of truth and master branch for future reference. All right, so moving right along here, almost done, just 2 more pages. So resources, network staff may not adapt to change as rapidly as other IT disciplines, mainly because the way networks are managed has not changed all that much over the past 30 years. However, network staff should always be looking for the most effective way to manage the network. Most will fully embrace this new methodology because of the power it unlocks and how much easier it will make their lives in the long run. Once the transition has been made, resources can be reallocated to more strategic projects. Ultimately, a stronger workforce emerges with modern, diverse problem-solving skills, software deployment principles, and basic coding abilities. There may not be a place for the CLI warrior in the next generation network. Okay. Which is honestly like, I kind of want to push back on that because, you know, there may not be a place for things that haven't worked for 30 years in the next generation network. Like, he said it himself. You know, it hasn't changed much for the past 30 years. You know why? Because it worked. Because we have networks that work and we have a global, you know, worldwide internet. Like, you know what else hasn't changed in the last 30 years? The Newton's laws of physics. So, you know, maybe this is a true statement. There may not be a place for the CLI warrior in the next generation network, but I would not count on that. I would say learn your CLI. And, okay, maybe it's not the place for it in the next generation network. But if you're on a Linux machine, Bash isn't going away. Like, it's really a bold statement to me to say, hey, over the past 30 years, this process has not changed that much. So, 5 years from now, it could completely go away. It's like, I'm pretty sure if it has not changed much over the past 30 years, it's because it works. All right. So next one is cost. Capital expenditure savings can be achieved using network automation. Instead of large, expensive, appliance-based NMS solutions or agent-based software solutions, build an in-house solution custom fit to the organization's needs. Even larger savings can be realized in operational expenditures. For example, canceling your NMS subscription. Time spent in manual CLS device-to-device configurations or information gathering is eliminated. Overtime incurred for after-hour changes is drastically reduced. Changes that took hours now take minutes. Large disruptive changes that take significantly less time and effort because the power of the automation engine is orchestrating and delivering the solution. There are huge benefits to any organization these are huge benefits to any organization and demonstrates an immediate return on investment, ROI. It is hard to put a price on having a central repository acting as a source of truth for the network. That I definitely agree with. All right, so provisioning. One capability to consider now that network management is automated is device provisioning. Provisioning new devices is a repeatable one-time task and an ideal candidate for automation. Some zero-touch provisioning solutions exist as part of NMS solutions. However, they are often complex and mileage may vary. Using a homegrown automation solution, several options are available to automate provisioning. However, these options still require one or two touches to the device. We're not even talking about device provisioning. Oh, perfect. Okay, so yeah, we're talking about provisioning new devices. So some zero-touch provisioning solutions exist as part of NMS solutions or directly on box, like for Arubas. However, they are often complex, and I agree with that. In my experience, it's been to the point where like for example, option 82 for VoIP phones, that's a form of zero-touch provisioning, but it's not standard unless it's like an IP phone. So sometimes trying to figure that out, the specifics of, because who in networking class, just automatically knows that it's option 82. You have to read that from a textbook. So you have to get the official documentation for the device you're using, which is probably behind a paywall, and it's often complex. And mileage may vary. Yeah, even when you figure it out, it's what you're doing is you're creating a situation where you can send the traffic required for zero-touch provisioning. So if that situation is not already present and you need the, chicken and an egg sort of thing. All right, so using a homegrown automation solution, several options are available to automate provisioning. However, these options still require one or two touches to the device. Exactly. An operator can generate an automated configuration using data models, dynamic templates, and the Ansible framework. Then they transfer the generated golden configuration to a USB drive and connect to the console, replacing the startup configuration of the device with a generated templated configuration. That I like. Alternatively, the operator can use the console to configure the device with bare minimum requirements to be delivered in place. Connect the device to the network and push the generated configuration over SSH using an Ansible playbook. The device requires some initial configuration for reachability, including a management IP address, SSH access over V2Y lines. You have to enable the SSH daemon usually, and configure the keys and set up a password and all that. And the appropriate uplink interfaces configured before delivering on site. Once installed and connected, the remaining golden configuration is put in place using the automation engine. So so you can get it down to one touch if you do like this first one is a one touch. They just put in the USB drive. But this is like a two touch method. Like, they put in a running config and then you touch it again remotely. Either method guarantees that all net new network devices adhere to the golden configuration with little to no effort from operators. Also, by using the new NDLC, a dedicated working branch represents an exact point in time in the master branch of when the device was added to the network. Peripheral changes made to accommodate the new device, for example, the uplinking device, routing tables, or any other changes beyond the newly provisioned device itself, are captured in the working branch. The ability to perform side-by-side historical comparisons from before and after the change is available in the TFS history viewer, along with it being automatically provisioned. The new device also comes with automatically generated documentation. So one of the things he forgets to say, or I don't know if he forgets, but one of the things from my own experience that is important to consider is what operating system do you want to run? Do you want to run just the default operating system for everyone? Okay, great. Well, then you can do this sort of thing. You can give a full USB drive with the full golden configuration, and they plug it in, they're good to go. You could also do this method where they just do some basic changes, and then you make another touch remotely and fill in the blanks. But let's say you want to use a specific operating system, either a newer one that's default or revert to an older one for whatever reason. Well, now you need an extra touch. Oftentimes, operating systems mean that commands do not persist. So like your whole golden configuration, the command syntax, certain commands themselves may be written differently. It's no longer a golden configuration if you want to change that operating system. So, and then not only that, sometimes you can't paste it on the device in the way you intend until you're at that new operating system. So this doesn't talk about that. I just wanted to bring that up because that's really important. An operator can generate an automated configuration, but that automated configuration is designed for an operating system, and the person installing the device, so the operator can use the console to configure the device with bare minimum requirements, has to be given a golden configuration compatible with that operating system. And if the operating system is meant to be changed, then they need to be given commands that are compatible with both operating systems. So when it boots up to an operating system, they either need to change it out. So it's just like, what I'm trying to say is more complicated than this, because like a lot of the times you don't want to use just the default operating system that it boots up to, because there could be bugs, because it could be out of date, all kinds of reasons, anything you could imagine. So this is a really simplified scenario, and the real world will often include operating system changes, which means that you can't hand off a USB drive with a golden configuration, because it's a golden configuration to what? To that new operating system. So the operating system that's on there is incompatible with the golden configuration. Everything's all different. Not only that, it's hard to, when you connect it in and put in the initial commands, well, now the initial commands are all different. So somebody has to figure out what the initial commands look like for each operating system that's ever going to be present on your network for any reason. And then when you connect to it, your automation now has to know that which operating system it's on, so it can enter the correct commands and update that operating system to the correct device. So it's never that easy, and that's one of the ways that it will be more complicated. Okay, so once installed and connected, once installed and connected, the remaining golden configuration is put in place on the automation using the automation engine, assuming that it is compatible with the current version of the operating system and that the current version of the operating system is the version you want. If that is not the case, then you need a special temporary golden configuration for your out-of-date operating system, and you want that golden configuration to be the commands required to update the operating system. And then after that, you need another golden configuration for the just a standard business as usual golden configuration for the operating system that you want to use. So either method guarantees that all yeah, I already read that. All right, so this side-by-side stuff is truly amazing, but it's more complicated than this, and that's just if you have a different operating system, it could be that they plug in the wrong model of device. So like now everything looks like it's good, but you do a show interfaces, this one has XFPs instead of SFP slots, so we can't use the right transceivers for them. It's always more complicated. This is simplified. All right, next section is source control. This is something automation can bring to your network, is source control. The following is another way of looking at source control in the context of network as code. If only code from the master branch is deployed to the network, the state of the network at any given point in time is known. If there are no out-of-band changes, the entire network and evolution of the network is captured in the master branch history. Controlling this source code is extremely important given the blast radius a problem on the network can have. Locking the master branch, forcing working branches for all changes, implementing strong role-based access control, and utilizing pull requests that required outside approvals are all forms of source control. TFS, which is like offers, which is basically just Azure. All right, version control, which is different than source control. Automated builds give a sense as to the version of the network code and device configurations. Using pull requests in TFS, changes from the working branch are merged into the master branch. This can trigger a automated build which captures the network's state. Data models, templates, playbooks, tasks, documentation, and git commit history are all included as artifacts in a build. Build numbers increment as the network undergoes changes and vice versa. Begin looking at the network like software. So the whole network can have an initial build of 1.0. Then you can add a new feature to the entire network. So like NetFlow on the distribution layer across all the buildings you have on your network. So then let's say something goes wrong with that. You can fix all the bugs, the logic, the bad data. And now you have a build 2.0, which includes NetFlow and the fixes you needed to do. So, and then since it's idempotent, you know that you truly are on version 2.0, and there's been no changes made beyond that. All right, so branching. A Git branching strategy should be adopted, and it should be kept simple. Make sure to include working branches for all changes, also known as feature branches or bug fix branches. Working branches should be limited in scope, containing a single change or feature. Within each working branch, use Git to commit changes frequently into the working branch. This allows for distributed deployment and multiple people to work on the same branch. Keep a high quality golden configuration as the master branch. Use pull requests to merge working branches into the master branch. So a Git branching guide is available here, which I might want to save because oh sweet, and there's a like a tutorial. All right, so here's the Git branching guide. This is Microsoft documentation. I'm going to save this. This might be good just to have. So here's my read through notes. I'm going to say Git branching guide. All right, and then this was on page 40. I guess the page number doesn't matter that much, but whatever. All right, and then we also have a tutorial here, like an interactive tutorial. So to learn more about Git branching, learn Git branching is a free online interactive training program available here. So I think I want to save this as well. I feel like I've done this before and it hasn't been like super helpful. Okay, so yep, here we go. So this is page 41, but we'll put it there, interactive Git branching guide. All right, on page 41. All right, and then I'll say stage these changes and go Git learning materials, commit and sync. Okay, and don't show that again. All right, back to the book. So yeah, we made it through all of chapter 2. Hooray. So the summary is the solution to many of the challenges faced by the modern enterprise is network automation. Networks have outgrown the original scale intended for the management plane, which, I mean, I feel like that's the solution, right? We should just have network. We should just expand the. Oh, well, I guess that's what we're doing, is expanding the scale of the management plane. All right, so network enterprises are now made up of hundreds, possibly thousands, of physical and virtual devices, and can no longer be managed by larger groups of human operators. I guess that's what I mean. It's like, why are enterprise networks made up of hundreds, if not thousands, of physical and virtual devices when they used to be made up of less than that? Like, can't we just have like the same number of devices, but with like more like more powerful devices? Like, why do we need more devices? And like the answer I can think of is like, because the distances, you know, it's like, how fast is the speed of light? You know, that's like, you're not going to make technological advancements in that regard. So like, you know, as there's more like sprawl, like, yeah, there's a point where you just need another device to like make a connection longer. You can't just make a larger device, because there's, you know, physical constants in the universe that you can't just overcome in however you want to overcome them. Like, adding more devices is the only possible solution. Like, physics works that way. All right, so enterprise networks are now, yep, there we go, can no longer be managed by larger groups of human operators. The resources required simply cannot keep pace with the demands of new technologies being deployed. And I kind of do want to ask, so I'm going to ask the AI something, just because I like talking to the AI. Okay, so there we go. I'm going to say, why is it that more devices, why is it that enterprise networks are now made up of more devices? couldn't it instead have been the case that instead of increasing the number of devices as the enterprise networks grow, as the networks grow, it could be that the same number of devices, it could be that the capacity of the devices of each device grows, but the number of devices stay the same. Why couldn't this have been the case instead? All right, and then I have one more question, and that is, additionally, why do why did the original scale have to grow so much? Why was the original scale so far underestimated? Now this I know far underestimated. And this I know because, like, you know, computers have gotten more powerful. But let's see what the AI says.
You've touched on an important issue that relates to network architecture, scalability, and design, topics that are highly relevant to your career goals, especially mastering network automation and understanding the industry from a bird's eye view. Why enterprise networks have more devices? Diversity of functions. Modern enterprise networks are expected to do more than just basic connectivity. They now support VoIP, video conferencing, cloud services, IoT devices, and more. Each specialized function might require specialized hardware, thereby increasing the number of devices. High availability and redundancy. Businesses can't afford downtime. Multiple devices offer failover capabilities, reducing single points of failure. Scalability. It's easier to add new devices to an existing structure than to replace one big device with an even bigger one. This incremental scalability allows enterprises to expand in modular fashion. Geographic distribution. Large enterprises often have multiple locations. Each location needs its own set of network devices. Cost. While high-capacity devices exist, they can be prohibitively expensive. Smaller, more numerous devices can sometimes perform the same functions more cost-effectively. Technological advancements. Newer types of devices, like software-defined networking controllers, may be added to modernize an older network, leading to a mix of old and new devices. Vendor ecosystems. Sometimes enterprises are locked into a vendor's ecosystem, which might require specific types of devices that increase the overall count. Why the original scale was underestimated. Rapid technological change. The pace of technological change is often faster than most people anticipate. When many networks were initially designed, the architects couldn't have foreseen today's demands. Business growth. Companies themselves grow, sometimes unpredictably. Mergers and acquisitions can also quickly double or triple the size of an enterprise, including its network. New types of traffic. The original design might not have anticipated the rise of video, cloud computing, and IoT, which can be bandwidth hogs. User behavior. With BYOD, bring your own device, policies, and increased mobile usage, the number of devices connecting to the network has grown, necessitating more robust network architecture. Regulatory and security concerns. Compliance with new regulations might require new monitoring and security devices. Lack of foresight. Honestly, sometimes it's human error. Network planning might not have been thorough, especially if the planners didn't expect the business to succeed or expand as much as it did. Considering your interest in...
All right, so that's great. Okay, so moving on. The resources required simply cannot keep pace with the demands of new technologies being deployed. Adopting network automation is an inevitability. The question is whether the technology is available, mature, stable, and production ready for the enterprise. As outlined in Chapter 3, How to Automate the Network, the tools are available, easy to adopt, and come with mature, well-defined processes. All right, so that's going to be the next video, is how to automate the network. Yeah, automation is an inevitability, so jump on that train. Don't be left behind. Stay tuned for the next video.